KCC105. We've been talking about representing large quantities. Let's see how that fits in with the topic of linear growth. In particular, we read an article talking about a big number like 400,000 people. How do you make sense of it? Well, the article used a hockey stadium. It says, well, if each stadium is 20,000 people, then 20 stadiums filled with people will equal 400,000. Another way to visualize that large number. And it makes sense, but the critical step to being able to break it down is we needed that rule. We needed that measurement. One stadium is 20,000 people. And not only did we take that measurement, we generalized it. We said each stadium is 20,000 people. Not just one stadium, but each stadium is 20,000 people. And when you have a situation like that, when you have a rule, a measurement that we can generalize, that is the heart of linear growth, saying every stadium is 20,000 people. A constant measurement that we can generalize is representing linear growth. Now, you might say, wait a minute, linear growth, I remember that being represented with numbers in a table, or a graph, or even an equation, y equals mx plus b. These are all accurate ways to represent linear growth as well. And we will see these. Moving forward, we'll be able to represent linear growth in all these different ways. But right now, I want to use a linear growth to just represent a large number, 400,000 people. I say, how big is 400,000? You give me an example, like, oh, well, it's 20,000 people per stadium. And then you divide it. You break it down. You say, take that big number, break it down, and say, 400,000 is the same as 20 hockey stadiums filled with people. So, you're taking these big quantities and you're breaking them down using that linear model. You need to come up with these examples. For class, think about these sort of things. Kind of brainstorm towards these. I'm using the stadium model. Brainstorm some other ideas. What do you say? Hey, every hour I earn $12 in my job. Notice it's a constant measurement. Every hour I earn this. What's another example? What if take something that in the kitchen, maybe it takes you 3 minutes to fillet a salmon. Every time I fillet a salmon, it takes me 3 minutes. So you see, it's a constant measurement. Those sort of representations are at the heart of linear growth. Some other examples. You could talk about over time. What about over a day? What do you do in one day? I ride a bike 14 miles. What do you do over a month? Well, over a month, I pay some money for my phone bill, car note, your rent. What about over an entire year? Maybe on average, I look up some statistics. Ice cream, 23 pounds of ice cream each year. All of these are linear growth, and you'll notice that each one you can think of in terms of every or each a constant measurement. So think about those and then understand how we can take a big number. Let's do $1 million in this case. Let's go back to my salary and say every hour I earn $12, and you can break it down using division. You say, wait a minute, take that big number, break it down with my linear growth model, and then we can get a representation. $1 million is the same as working my job for 83,333.3 hours. That's an accurate representation. It might not be the most helpful. For instance, all those hours, that's hard to make sense of. Maybe you want to break it down even further into days. So these are the next steps that you'll consider on your own. And where do we lead? Next week, we look at things like the graph. We look at things like the table. We look at things like the equation. We're going to build on top of these representations. So if you're thinking about all our learning objectives, right now, I want you to understand basic examples, every stadium, each hour, and I want you to understand how we're going to use those to represent large numbers. So based on those two learning objectives, we're going to apply them in class, but before we get there, I also want you to log on here real quick. 3 questions. Just tell me that you absorbed the main ideas of this lesson. So I'll look for you to log in here, get that information, finish those quizzes, and then in class, we're going to be applying those objectives.